submit it.
Okay.
Just because it's a take-home quiz, I don't want to get it wrong for some reason.
Yeah.
Uh, okay. I think all three of them are in there. Do you see them?
Yeah. Give me one sec.
Cool.
I'll be live streaming this, so.
Okay, no problem.
All right. Bigger here. All right. So what is the value of f prime for that? So yeah, for this one, for the one on the left, you're going to want to see if this pen is right and big enough. Nope. There we go. You see it okay?
Yep.
Okay. So you want to rewrite this? I would rewrite this as, sorry, give me a second. I'm having a hard time with this. All right, y equals 3x squared plus 3 times x to the 2/3, I think, right?
Yeah.
So then the derivative is going to be 6x plus 2x to the negative 1/3,
Yep.
and then plug in -8. So 6 times -8 plus 2 times -8 to the 1/3, negative 1/3, which
Hmm.
is -48 plus 2 over -2, right?
Yeah.
You got that? You got how I did that? So that's
Oh,
-49.
yeah. Okay.
Get it?
Yep.
Number one, the one at the bottom, it says, which of the following is the graph of the line normal to the graph of that at that? So the normal, so first you're going to take the derivative of that, and and then you're going to find the slope of that. So that would be 6x to the fifth minus 3x squared minus 1 plus 1/2 over root x. Get how I did
Yep.
that?
Yep.
And then plug in 1 for that, and you're going to get 6 minus 3 minus 1 plus 1/2. So that's 2.5, just 5/2,
5 halves, right?
right? And then, but
We flip
that's
it.
the, yeah, you'd have to take the negative of it, right? You don't just
Yeah.
flip it. So
Yeah.
it's the
We're
negative
opposite
reciprocal.
reciprocal. Yeah.
So that's your slope.
And how do you find the
And
y-intercept? That's what I didn't know how to do.
so those are your two choices there. And then the y-intercept, you plug in 1. You plug in 1 for that to get a point. And your point would be 1 comma. When you plug in 1, you get 1. You get, I think, just 1, don't you?
But wouldn't you have to plug in 0 for the y-intercept, not 1?
No, you're finding another point. You're finding another point, and then you're plugging it into the point slope equation of the line.
Oh, okay.
So I think it's 1, right? Isn't it 1?
Let me double check.
Let's see, it's 1 minus 1 minus 1 plus 1 plus 1.
Yeah, so it should just be 1.
Yeah, so that's your equation, and then if you distribute that in, it's -2/5 x plus 2/5 plus 1 equals y. So 5/5. So that would be 7/5.
Got it.
Got it? So
Yep.
that's that one. And then this last one. Hey, Vincent, by the way, you can put your questions on there, Vincent. I'll be with you in a sec, okay? Oh, shoot. Did I not? Did I not? Yeah, I let him in. Vincent, you hear me? All right. I think he's maybe just.
Yeah, sorry, I was just muted.
Okay, no worries. Yeah, go ahead and put your questions in there separately, and I'll get to them in a sec. All right, so find the derivative of that. So again, you're just taking the derivative. So that would be 6 over pi times x minus 8 cosine of x.
Yeah.
So then when you plug in 2 pi over 3 for x, those cancel. You get 2, those cancel. So you just get 4 minus, what's the cosine of 2 pi over 3?
Uh,
The cosine would be the x, so it's negative something.
Negative
It's here's 1 pi over 3, here's 2 pi over 3. So that's the bigger one. That's
√3/2.
I'm sorry, no, that's the smaller one.
Oh,
1/2.
1/2.
Yeah, so it'd be -1/2.
Okay.
Wait, I didn't plug that in right though yet. That's 8 times -1/2. So that's plus 4. So the answer should be 8, I think.
Yep. That's an answer choice.
Okay, good.
Yep. That's all I had for you.
All right, buddy.
Thank you, Mr. Dwyer.
Yeah, no problem.
All right. Have a good evening.
You too. This should be on YouTube too if you need to see it.
Okay. Awesome. Thanks. Bye.
See you. All right. How you doing, Vincent?
Pretty good.
What are we working on here?
Just a unit circle, like him, I think, from what I
Okay.
heard.
It was just one question that happened to be from the unit circle.
Yeah.
Do you have your unit circle all written out?
I do, yes.
I mean, you can do it real quick, right? You know how to
Mm-hmm.
do it yourself real quick? Just take,
Just
let's
the
make
first
one,
quadrant.
yep, make one line. Whoops, hold on. Make one line that cuts through perfectly. That's your 45-degree angles. We'll make that red. Okay, and then make a line that cuts through at a 30-degree, so like there.
Mm-hmm.
And then that would also be somewhere like that. And then make a line that cuts through at a 40 or a 60-degree. Should be something like that. And something like that. Okay. And then your numbers, the easiest way to do this is just to think about those triangles, right? So that green triangle that's right there, that's going to be a 60, 30, 90 triangle, right? So that's a 60-degree angle at the base there. And the point is going to be 1/2 comma √3/2. Got it?
Yep.
And so this point right here, this right here, is going to be another 60 degrees away. So that's 120 degrees. And it's going to be the same point, except it's going to be a negative x coordinate with the positive y coordinate. You get why?
I think so.
And this point's another 60 away. So 60 from, I'm sorry, this is 120, first of all. Then another 60 from 180 would be 240 degrees.
Mm-hmm.
Or you could have
Okay.
taken this and just added 180 to it, right? Same difference. Taking the 60 degrees because it's just straight down from that, right? And so that point is going to be, both of them are going to be negative, but the same values, the same absolute values. Got it? Because it's the same triangle. All these green ones are just the same triangle.
Yep. Except for different like signs, negative or positive.
Yep, exactly. Except for different. You see why that didn't work? Oh man, it's erasing the whole line. I don't like that. I want to just to erase part of the line. How do I get it to do that?
I think you have to redraw the entire line for some reason.
Oh, that's weird. All right, anyway, I won't do it. And then the green, this one right here would be, again, same difference, except it's now you're going to add, it's -60, so it's 300 degrees, and it's positive x and negative y. So all those green triangles are the same, and the same can be said for the blue, except the blue one just gets flipped, right? It's the same triangle, it's just flipped. So it's √3/2, comma 1/2 for all these. So this is negative √3/2, comma 1/2. This is negative √3/2, comma negative 1/2. And this is √3/2, comma negative 1/2. Got it?
Okay.
Have you done this yet she makes you, or he makes you write out the whole thing like in 3 minutes?
Not in 3 minutes, no.
Yeah. It's probably something you'll be doing soon, but it's definitely a good thing to practice. And then the red
Oh,
ones are just √2/2, √2/2.
yep. Each time it's changing 90.
Yeah. And then again, this is negative positive.
Where do you want me to go?
This is negative negative. Hey Josh, you can just put it anywhere in the blank space that you see, maybe on the left side of where I'm working. And that one's positive negative. Okay. Good.
Oh shoot.
You got it, Vincent?
I kind of froze for a second. Can you repeat what you just said?
Yeah, so the red one is all the 45-degree angles, 45, 45, 90. So all those triangles, all those red triangles are basically the
Yeah.
√2/2, √2/2. √2/2, √2/2.
Yeah, okay. I think
And,
I
and
got
then
that.
you just put the positive, negative and stuff. Are you trying to mess with me
What?
rotating this?
It was upside down when I got here, so I just fixed it.
No, now it's upside down.
It was upside down for me just now, and then I fixed it, and now it's the right way up.
No, it's not. It's upside down. Are
For
you
me, it's the
kidding?
right way up now. No, I'm not kidding.
Wait, so you've been seeing this whole thing that I've been doing upside down?
No, just the image. As soon as I froze, that appeared upside
What?
down, and I don't know, just technical difficulties.
Okay, well, right now
I
it's
have the real
upside
papers.
down.
Just go ahead and flip it your way, since I have the actual paper, I guess.
On the video, it's going to be flipped if something happened with I
I'm
don't know
gonna
what
have to
happened.
check that out.
That's hilarious. I was wondering what you were doing, messing with the image. That's funny. Okay. Anyway, so now you can just use that to find all the values. And then if you want to find the tangent, remember the tangent is the sine over the cosine, right? So
Hmm.
the tangent is just the y over the x on
And
these
then
points.
cotangent is x over y or cosine over sine.
Right.
Hmm.
Or the
Okay.
flip of the tangent. So what I like to do on my unit circle is just write in the those values. So this would be 1/√3. This would be 1, and this would be √3.
Do you even need to show any work for this kind of thing, or do you
Not
just kind of
really.
like know?
Yeah,
Yeah,
you
just
don't
write
have
it
to show
down.
work. Just write it down.
So
That's
like for
kind
the
of the
first,
point. Yeah, that's
yeah,
kind of the point of the unit circle.
for the first one, problem B, or like just in general, she says like each answer has like an assigned number to it. So like how on the first set of problems, -1 is 8, and then on the backside you get to like put them into like a Sudoku kind of
Oh, right.
three by three block thing.
Yep.
And so do you think I should say like the 8 or the -1 in that case?
No, you write 8 into the Sudoku block. Yeah, for that.
But into like the problem set one, like right here, would I write 8
Oh,
or -1?
I would write -1 in here,
Yeah, okay.
and then maybe write 8 in the lower corner.
Okay, yeah.
I don't know, because I
All
think
right.
8 is the thing that you have to carry over. Okay.
Okay,
Do you
thank
want
you.
do you want to do you want me to work those out, or you feel like you get that now?
I think so far I've got it.
And do you know the best way to count by um, radians? Have I shown
No.
you that? Okay, so radians are actually easier than degrees, in my opinion, once you figure out how to do it. So here's how you do radians. Let's do the blue one first. Okay, look at my blue lines on the graph.
Yep.
So those blue lines, that's a 30-degree angle, right? And so all the blue, if you look at it, if I do 30, 30, 30, 30, you see how I'm doing little lines of
Yeah.
there's six 30 degrees in pi radians, right?
So it's pi over 6.
So this is pi 1 pi over 6. The green one is 2 pi over 6.
Or just pi
Yeah,
over
but
3.
we'll just keep doing it like this. 3 pi over 6, 4 pi over 6. Get the red. 5 pi over 6. This
And
is
this is
6 pi
pi.
over 6. 7 pi over 6. This is 8 pi over 6. This is 9 pi over 6. This is 10 pi over 6. And
Mm-hmm.
this is 11 pi over 6. And this is 12 pi over 6, which is 2 pi. And now you can go and cancel all those, right? That's pi over 3. That's pi over 2. That's 2 pi over 3. That's 5 pi over 3. That's 7 pi over 6. That's 4 pi over 3. That's 3 pi over 2. That's 5 pi over 3. And that's 11 pi over 6. And then for the red one, you can do that as well. There's four. One, two, three, four. There's four of those angles. So that's a 45, right? That's a 45. So that's pi over 4, right? This is
Mm-hmm.
2 pi
Yeah.
over 4, which is pi over 2. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4, which is 3 pi over 2. This is 7 pi over 4. And this is 8 pi over 4, which is 2 pi.
Yeah. Okay, I think that
So
makes
just
sense.
learning to count by pi radians, or by fractions of a pi radian, is actually not really hard to do. And once you do it that way, now you can go in the negative direction as well, right? That you could call this negative pi over 6, this negative pi over 3, negative pi over 2, negative um, 2 pi over 3, because it's a green one. Whoops, negative 2 pi over 3, etc. Right? You can call this negative pi over 4 if you wanted to. This one here, right? Because you can count in the positive direction or the negative
Mm-hmm.
direction.
Yeah. And
Okay.
you can go more than 2 pi and so on and so forth.
Exactly. Yep. And you can keep going. So this could also be 13 pi over 6 right here. That this could
Yep.
be 8. This could be 9 pi over 4. Right? Those are called coterminal.
All right. Yep.
Okay. Good.
Yeah, I think that makes sense.
All right, man.
I will, I think that's all I had. So I will see you Thursday then.
Sounds good. Bye, Vincent.
Bye-bye.
All right. Hey, Josh. How you doing, bud?
How's it going, man? Sorry, I literally just got my homework loaded up on here. It took me a minute to
Oh, no
figure out how
worries.
to get off my phone. So I didn't really get the
Yeah.
chance to work on it. So
No, that's okay. That's okay.
um
Where did you put it at?
I put it all the way over to the left. If you zoom out really
Left.
far,
Yeah,
yeah.
I got you. I got you.
So today we talked about, I don't think I'm struggling really right now because we're just doing physics, and I took honors physics, which is essentially the same thing as AP Physics 1.
Yeah.
I really enjoyed that. It was super fun for me. It was really easy too. So right now I'm not struggling that much
Okay.
with other things that we're doing, but today we pretty much just did a worksheet on, let's see, like water going in and out of a cylinder and how to graph it, or no, give us the equation for volume and time. And
Yeah.
then we're working tomorrow, we're gonna do cylinders
Okay.
because you have to take the derivative of it since it's decreasing as the
Yep.
water level goes down. But this was the homework that I've pasted in for today. I didn't even read it yet. I
Okay.
just got it posted in there.
All right. Well, why don't you tell me what to do? I'll write. I'll write it because I've got it on an iPad. It's easy for me.
All
You tell
right.
me what to write. So it says let R be the radius and H be the height, both measured in inches. Let T be the time measured in seconds. The height of the cylinder remains constant at 7. The height remains constant at 7.
Yeah, so height is 7. I
So
think, is it the same equation? Just
right.
pi r squared times height.
Yeah, what are we talking about? A cylinder?
Yeah.
Yeah, a cylinder is just going to be, are we talking volume here?
Yeah.
Yeah, so the volume of a cylinder is the radius. It's the radius. I'm sorry, it's the area of the circle. So pi r squared,
Yeah.
and then the height. Yep, you guys can multiply it by the height. Yep.
So 7 and the
Identify it.
radius of the, oh my bad. And the radius of the
Yes.
cylinder is decreasing under 3 inches per second.
So the
So
what should I write for radius of cylinder? Decreasing.
uh dv dt, wait, hold up. If it's decreasing at 3 inches per second, I don't know. I didn't do a problem like this. We did
So it would be negative. dv dt. You're right. dv dt would be negative 3 inches per second.
yeah,
So
and then
that's
that
dv
would
dt.
be, oh, okay.
Okay.
So
So it
yeah,
says identify the rate of change of R with respect to time and indicates the units. Rate of change of R. So they want dr dt,
for A,
right?
yeah,
That's what they want. They want dr dt. So we have to take this formula and take the derivative of it, right?
yeah,
dv dt would be, well, we know that the height is constant. So the height is just 7. So
yeah,
let's just put 7 in here. So 7 times 2, right? Taking the derivative, that would be
yeah,
14
49.
pi.
Oh wait, no, I'm stupid, not squared.
Yeah, 14 pi times r
Yeah,
would be with respect to the rate of r with respect to time. So
time, yeah.
dv. So sorry, then I'm sorry, and then I multiply it by dr dt.
All right.
You understand why?
Yeah, because you're taking it with respect to time. Everything's under time.
Yeah, it's the chain rule. That's why
Yeah.
you're doing the chain rule and implicit differentiation, I think, is what it's called.
Yeah, I
So
didn't really
d
get my bad. I wasn't really paying attention like earlier in the year as much, so I kind of missed. Like I know how to do chain rule, quotient rule. I didn't memorize like what the equations are, but if it's given to me on a test, I know how to use them, if that
Yeah,
makes
I got it.
sense.
Yep,
Um,
yep.
didn't really pay attention for implicit and explicit differentiation, but I know how to do them. I don't know which one's which. I think explicit's just solving for y, and then the other one's using derivatives, but my memory's kind of
Yeah, implicit is kind of like when you have more than one variable and
yeah,
you got to take the derivative of everything with respect to a different thing.
yeah,
So we're taking the derivative of this equation right here. I'll call
volume.
it 7 pi r squared. We're taking the derivative of that with respect to time.
Yeah,
And so it's kind of like you're distributing this into both of those. So dv dt equals, now take the derivative of it. It's kind of like the chain rule, right? You got to take the derivative of it, but then you also have to multiply it by the derivative of the inside, which is
yeah,
r. So 14 pi dr dt. I'm sorry, 14 pi r dr dt.
yeah,
Got the r, right? 14 pi r, that's the derivative of the outer function with the inner function r unchanged. But now you have to multiply that by the derivative of the inner function, which is the chain rule. So the chain rule is when you have a function on the outside, like squared, and you have a function on the inside, 2x squared plus 5x.
yeah.
To
So
take the derivative of that, I first take the derivative of the outer function. Let's say that was 3, not 2, just so it's
yeah,
easy. You do that, and you leave the inner function unchanged, right? That's chain rule.
yeah,
And
and
then
then
you
multiply by
multiply.
the derivative of the inner function.
You got it, exactly. So that's what I'm doing right here.
All right.
Okay. But
Yeah,
now I'm plugging in what they told me. They told me that dv/dt was -3. So now I'm plugging in -3. And with respect to identify the rate of change of R with respect to time. So I'm trying to find dr dt.
Yeah,
So
so
I'm
then,
solving for that, right?
yeah, so then move everything over. Um, divide
Yeah,
by 14 pi r
exactly. You got it. So -3 over 14 pi r
equals dr dt.
equals dr dt. Is that right? Identify the rate of change of R with respect to time. Yeah, I think that's it. I think that's the right answer. Do you have the answer key?
Yeah, let me check on Google Classroom real quick. Um, answer key.
So the rate of part B looks like a trick question. The height isn't ever changing.
Identify the rate of change of the height of the cylinder with respect to time.
So I would
So,
just say dH dt equals 0.
yeah, because height's constant.
Yeah. And then it says the area of the circular top of the cylinder is given by that, which of the following statements? Which of the following statements about the rate of change of the area of the top, which of the time is true? dA. So what are they trying to say? They're saying like if you wrote this instead, VC equals A times 7, area times height.
Yeah,
Maybe if you do it that way, rate of change of the area. So yeah, so if we did it with that, if we found, so V equals 7A, and if I took the derivative with respect to time of that, it would just be dV dt equals
equals 7
7 dA dt,
dt.
right?
Yeah,
And dV dt was -3.
yeah, so just -21.
No, divided.
Oh, yeah,
-3/7 equals dA dt. Is that one of my options?
yeah, so 2 or 3.
Um, wait, I don't get what they're saying.
2 pi
Which of the following
square
statements
inches
about
per
the rate of
second or 2 pi r square inches per second.
I don't really understand. Did we get A right? A and B? Did you
Yeah,
find the
I'm
answer
trying
key?
to check. He has like, let's see, notes, homework, day one. He posts like a blank one and then answer key and then oh, here's the actual homework one. All right. A is -3. Yeah, that was right. B 0 and then C is 3.
Part three. Okay, so I don't quite get the question. Trying and I don't understand. I can't. It's hard for me to read the answers as well.
Yeah.
But so dAdt, they don't really want dAdt. Doesn't look like it. Equals dr dt times 2 pi r square inches less than 0. dAdt equals. So the other thing they're saying, they're also doing this. They're also saying A equals, this is maybe what they're doing, pi r squared.
Yeah.
A equals pi r squared. Now take the derivative of this with respect to time.
Mm,
I think that's what they're doing.
yeah.
So they're
So
doing dA dt and then do that same thing we did before. 2 pi r dr dt. You get that?
yeah, I see that.
I think
And
that's
then
what
we
I,
already solved for A.
yeah, and then we already knew that it was going to be negative based
Yeah.
upon, yeah, I think that's what they're doing. Yeah. Anyway, makes sense?
Yep.
All right. Is this Calc AB or BC?
This is AB.
Wow, I've not seen that. What school are you at again?
I'm at Mattia.
Okay, I haven't seen this before. I haven't seen them do this like the physics angle. Your
Yeah,
teacher
no.
must be a physics guy.
Mr. Dom, bro. No, he's really young. I don't know. He doesn't really teach. Like he's kind of like a college teacher. He's just like, "Hey, you're doing this today. Yeah, if you get it, you get it. If you don't, you don't. We're gonna go over answers." Um, that's pretty much it.
Well, well,
But most of the kids seem to be doing okay.
figuring it out. Yeah.
Yeah, a little bit. I don't know. There's a lot of YouTube video watching in your free time.
Right, exactly. Yeah. If only I had that when I was your age. All right,
Yeah.
number two. You want me to do number two or which one?
Yeah.
Okay, the volume of a cube in a cubic centimeters grows as the length of the edge grows. Okay, so we've got a cube.
Yeah.
So a cube, all the sides are the same, right?
Yeah.
So the volume is equal to, what are they using? X? Are they using X or L?
L
L.
for length.
L cubed. So the volume grows as the edge of the cube grows, okay? So
Yeah.
write an equation for the volume of the cube with edges of length L. So there we go. We just did that.
Yeah.
Use implicit differentiation to write an equation for dv dt. Okay. So dv dt. Remember what I was showing you? I'm just going to do it like this. It's like I'm taking that for the entire equation, right? Does that make sense how I'm doing
Yeah.
that? So that's dv dt equals, now let's take the derivative and leave L unchanged and then multiply it by the derivative with respect to t, right? That's the chain rule.
Yeah.
Got it? So then use it to write an equation for dv dt, the rate of change of volume of the cube with respect to time. So there's your equation. That's that. After t equals 3, the length of the edge of the cube is 7 centimeters, and the length of the edge of the cube is increasing at a rate of, so this is dl dt, right? It's increasing, so it's positive. It
Yeah.
says use your equation from B to find dv dt. So dv dt at that instant is going to be 3 times, it says L is 7, so 7 squared times dl dt, which is 2. So at time t equals 3, I didn't even have to write 3 in there ever,
Yeah. So
right?
49 times 3 times 2.
49 times 6. So 50 times 6 is 300 minus 6, 294.
Yep.
Did I do that right?
Yeah.
Got it? D, the length of the edge of the cube in centimeters is a function of time in seconds and is given by that. Okay, so now they're giving us an equation or they're telling us the length is actually an equation relating to time. Write an equation for V, so this is composing functions together. So the volume would be equal to that cubed, 2t plus 1, because that's the length cubed. So there's your equation. You get how I did
Yeah.
that?
Yeah.
It says use your equation from part D to find the rate of change of volume of the cube with respect to time at the instant when t equals 3. So let's do that same thing. Let's do, I'm trying to think if I can just plug it in. Or if I have to redo it. I kind of feel like let's just redo it. So dv dt equals, I'm taking the derivative with respect to time. So 3, 2t plus 1 squared times the derivative of the inner function, which is just 2. It says use your equation to find the rate of change of volume. So the rate of change of the volume. So they want dv dt with
Yeah.
respect to time at the instant of 3. So now just plug in 3. When t equals 3, just plug it in. So it's 3 times 6 plus 1 squared times 2. Is that the same answer?
Yeah, I believe so.
249 or 294.
Yeah.
Can you check the answers, see if they're the same for D and E?
Yeah. Looks like yeah, V equals L cubed. DVDT equals DLTT times 3L squared.
C and E is really what I'm talking about. Is the answer for both those 294?
Yeah. 294 and D is same thing you've written, yeah.
Yeah. Okay. So it says describe the similarities and differences in the approaches. Given summary is a function of time and seconds. I'm just not sure where they came up with that equation for the length of the edge of a cube in centimeters is a function of time and seconds and given by that. I don't know if that's always the case or if I'm actually not sure how to answer letter F. It says describe the similar to the two approaches used in C and E at 3 seconds times T. The length of a cube is a function of time in seconds and is given by that. You know what I'm saying? Like I don't know if they just came up with
Yeah.
that or if C if I don't really know how to help you with letter F.
Yeah, I can read the answer. It just
Yeah,
says, in part C, we used implicit differentiation to find the rate of change of volume directly in terms of L. To use this equation, we needed the length of the cube and the rate of change of the length of the cube at t equals 3. In part E, we wrote an equation for volume in terms of t throughout the composition of functions, or
yeah,
and then found its rate of change. To use this equation, we only needed to substitute t equals 3.
yeah. I mean, yeah, that's what I did, right?
Yeah,
That's essentially what we did, but I just don't know where they came up with this. I guess I'm just thinking too deeply about it.
yeah.
But yeah, yeah. I guess we kind of did do that as I was doing it. I was describing it. That's what we're doing. Anyway, see if we have time. We got 3 minutes. Let's do. You want to do 3 or 4?
Let's just try 3 because 4 looks like what we already did in class.
Okay. Construction crews digging a cylindrical
Okay.
well
Radius of 2 feet.
deep in the well.
Construction.
Okay. So the crew is able to deepen the well at a rate. Anytime you see this, just write out the rate is the depth of it. So that's the height. So dH dt. Always try to name your variables when you can. Equals 15 feet per hour. That's the rate that they're deepening the well. They're increasing the height, right? Of the
Yeah,
and the cylindrical well has a radius, so the radius is always set at 2. I think the volume of a cylinder with radius r and height h is given by, yeah, we already did that. We already knew that. Which variable is remaining constant?
radius.
So that's the radius.
Yeah.
And replace the value of the equation for given. All right, so that's the volume equals 4 pi times h.
Yep.
Find dv/dt, taking the derivative. Don't forget the chain rule. It's kind of like they're explaining to us. This is number 3, but this should have been number 1. They're
Yeah.
like helping us think through it, right? So that's 4 pi dh dt, right?
Yeah.
No chain rule really needed in that case because we didn't have any complex functions. Find the rate at which the volume of the well is increasing. The rate at which the volume of the well is increasing, indicating, which is I think we did. Find the rate at which. Oh, I'm sorry. No, they said so. dH dt is 15. There we go. So dv dt. Now I'm going to plug in 15 for dH dt because they already
So
gave that to us.
yeah, so just 60 pi,
So it's just 60 pi, and then use the units.
feet per set, or yeah, feet per hour.
Feet per hour as well. Yeah. Oh, nope. It'd be feet squared volume. It'd be feet
Mm,
cubed. Feet cubed per hour. Right? Because
yeah.
volume is a cubic function.
All right, that looks good.
Good? You feel
So I
good about
think,
it?
yeah, I think tonight's just volume practice, and then tomorrow we'll work on, or tonight's cylinders, and then tomorrow's cones.
Oh yeah, cool. Yeah, that's basically it. I mean, you seem like you're pretty brilliant, so I think you're gonna be good. You just probably just need the discipline of actually doing your work and memorizing it and making sure you're not making mistakes.
Yeah, same thing with just memorizing all the things when like we're talking